So this is import all the libraries you think you can use. So sometimes you may miss out some. Maybe when you get to the place where you need to use them, you can really import them again. But I just kind of imported a bunch of libraries I think I will be using for this. So let me just restart this, and so we'll just run through the notebook together. So let's see. So let's run that. So why that is important, then we read the data. So when you talk about, so this is something I really wanted to address when you reading parts. So there's what we call absolute parts and relative parts. Absolute part is where I think some of you did that. You just copy the parts to the data where you have the data. So if you go on your, so this is what you can call this an absolute part. But in case of relative parts, so if you look at my folder, for example, under this week 5, this is where my data, this is where my notebook is. So under the notebook, I have a folder called data, and inside the data, that's where the thing. So let me open it up on the, let me open it up on my, yes, on the process. Just so I thought to mention that so you understand the difference between when you look at absolute. So this is the nature of my folder structure. So this is the solution I'm working on. So under this under this folder, I have another folder called data, and it's inside the data. That's where I stored the data I want to work with. So that's why in this case I'm using a relative part to put in the data. So it's more like from where you are, open the data folder and read out this information from it. So, for example, if I put this without the data, if I run this without this data, saying data, is going to return an error because under the folder where the notebook is, there is no file called this. But if I want to say, okay, it's not in this folder, but inside another folder, by the time I do the data, then open up the data, you find it. This would work. But for example, if the notebook is in a folder and I want to go back, I could just use dot dot that to say, okay, go back one folder. So I think it's a different part of programming, but I thought to mention, I think one of you brought it up as well, so that's why I thought to mention. So you could either use relative part or use absolute parts in what you're working with, but just have to understand your folder structure and the notebook you're working with, where is it located, then that's where you can use relative part. Okay, so I just read my data. I think I had that index column, so I just dropped the index column because I don't want it. Then I have my data, just did a copy of that. Then this just gives you an info of the data just to show what data is float, string, or object type. Then you could do your summary statistics. Just do print or describes the data. So what's your mean, what's your standard deviation, things like that for each of the column. Okay, so if that runs, then you can do a count of the targets. I want you to say, okay, my target variable, just before I start, let me be sure I have both values together. So this is what this does. So it shows that I have about let's say 70% of zeros and 30% of one. So I did a pie chart to just show that distribution. Like I said, visualizations most times is better because you can now mentally at least it communicates your results better. So I think this is where this would come in. Then now I wanted to, now in my data I told you that I have some numeric values and I have some categorical values. So I wanted to separate the numeric values from the categorical values, so that this is what this would do. So using this dot select type, include np.number, so all the ones that are numbers. So you notice that all these are numbers. Then you can do categorical values to all the ones that are not and they are not numbers to get it. So I have two lists now, a list containing my numeric features and a list containing my categorical features. Then I could just plot histogram, like you said, Paul. It depends on, you can immediately you read your data, you want to visualize and see what that looks like. So this is just shows like the distribution of my data for each of the columns to see, okay, what are the range of data I have. So this is what you have. So for the air temperature, you have this kind of normal distribution. In other case, you have some, okay, in other cases, you have the asymmetric distribution. You could also do Barplot. I'm not going to do Barplot because it takes a lot of time to run. So I'll just leave that for now. Then you can run a box plot. What does this box plot shows you? It just shows you the distribution of the number of your the data distribution for each of your numeric columns. In this case, I'm doing for the numeric features. Yeah, using the numeric features list. Yeah, so with this, you can already have an idea of the ranges in your data. So, for example, conductivity, I have from about 0 to about 2000 in the data for surface. So this can just show you all the columns that you have larger numbers compared to the others. So that's what you can also say, for example, with all the smaller ones, okay, I want to really see it well, then you can plot the box plot for the individual columns to see, okay, what's the distribution. So for example, from this, I'm not able to really tell the distribution of pH, but with this I can say, okay, my pH is likely between 2 and 12, ion is between 0 and 12.5. So this just gives you an idea of the data distribution if you can view it anyway. Okay, then for the categorical plot, I just wanted to see the distribution based on the target variable. So how many faint yellow I have, different colors you have, and how it affects the distribution. So for example, for colorless, you have a lot of them as 0, like, and a few of them also as wrong. Well, yeah, it's strange to see that you have some yellow water that it still had 0, because yeah, I think for the 0 in itself was, sorry, let me just go through what the column description is again. It's column distribution. So 0 meets standard, 1 does not meet the standard. So it depends on what you want to use the water for. So this just shows those distributions. Okay, so you could also plot some scatter plots. You say, okay, I want to just plot different variables to see if I can spot any trend, and also plotted it based on the target variable as well. So this using so I'm using the Seaborn to plot this to just see the different variables. So with this, I can't really see any kind of correlation at all with the data. Then I do the correlation metrics. There are lots of, with this case, there are lots of variables, so it's not really coming out as clear. So I can choose to increase this. So let me make it 20, for example, and run this again. So there are different features. You see, at least the highest I can see so far is about 0.2, 0.25, nothing, and it is very weak correlation. So, and yeah, with the target variables. So then we now start going into, now I've seen my data, I have an understanding of what the data looks like. I can now start looking, okay, how do I clean the data? Okay, so first of all, I want to see what's the sum. So Jude, if you see, I just used sum here, I didn't have to use double sum. So if you just, okay, I want to see the missing values, and you see that, okay, at least most of my columns have a few missing values. So this is the shape, just to see how many rows and how many columns I have in the data. So now we're talking about missing values. So you could do the missing values based on the columns, how many columns you have. Then also you can choose to do missing values. I want to see how many rows have missing values. So I just want to see for the rows, for example, the rows, how many of those, for example, if you look at the row 1, how many columns were missing. Since like I said, this is where I did this missing from missing. So I did the missing is any dot sum, but in this case I'm using axis are 1 equals to 1, so it will be along the first axis, like one axis. If you talk about data frame, you have axis zeros, that's your rows, and axis 1, that's your column. And when you do your dot sum, it sums automatically along the 0 axis. But in this case, I want it to be the 1 axis. So I also want to just get a percentage. For example, if you say, let's do df.shape, it's 23 columns. So for example, if you count how many how many missing columns in each of the rows. And for example, we have about 66 or 67,000 rows without any missing value where all the columns are complete. Then for, I think this should be one for, so we have about 27 rows, 27,000 rows where at least where one just it's just one missing value. Then you have about, this will be like two values. So I just wanted to see a distribution such that if I decide to drop missing values, so before I do this, so if I decide to drop missing values, I should have, so let me do something. If I decide to drop all the missing values at this point, I should have at least 66.9 rows. So if I do df dot drop na, if I return this, I should have at least 66,901 rows without any missing values. So there are different ways you can address missing values. In some cases, you can choose to drop. In some cases, you can. So if you want to drop, you know that you're losing about 30% or 30 something percent of your data. So you have to know. So that's where it depends on what you want to do. You need to look at that. Then I can choose to visualize where I have the missing values. So in this case, for example, you could see that for P, so this is just the rows from 0 to the 100,000 according to rows. You can see where I have missing values. So for pH, I just have a few missing values around there for all that. So you just have an idea of, so the yellow symbolizes where you have missing values and the purple where you don't have missing values. Okay, is that clear enough? Yeah, is that clear enough? So this just shows you the count of the missing values in each of the columns. So and to as so this just sort, okay, sort states, blah blah blah. Okay, I've done this. Drop any. So now, there are different ways to fill missing values. So for example, for the numeric features, I just fill numeric features with min. So Jude, just so that you don't have to do for all the columns individually. So you could just get a list of the columns you want to fill. You want to fill the missing values with, and you just call in the columns, and it fills with the missing value for each of the columns. So in this case now, all our missing values for the numeric column has been filled. While for the categorical values, I wanted to just fill with the mode. In some cases, I could just, so in this case, I filled with mode. I could use, let me see, I could, so instead of filling with the mode, I could try to fill with unknown so that I don't have it as, so for example, I can say dot fill NA with unknown, like I think who did it, was it Jude now, unknown. So you have a category called unknown rather than trying to fill with a missing, fill with them, rather than trying to fill with mode, you could just fill with unknown. I think that's still fine as well. Do we have categorical features? I think we've defined our categorical features earlier, so we didn't have to define again. So we already have this. So for now, I can toggle this off and just fill. In this case, let's just fill with the unknown so that we don't fill with mode. Then if you do this, so now we fill that. Then if I now say I want to print out the same chart I had initially, just to confirm if everything has been filled, I'll just run this again. Okay, so what's the problem in this case? Missing value. So let's just do this. Let's be sure that we've not missed anything out. Let's see. This is still, so what did we do? df.sum. Okay, I think I didn't. Did I run this? Okay, I didn't run that. That was why. So if we run this again, this has been filled. And if we run this would be, yeah, you see everything has been filled. Okay, I don't really need this anymore because I've done it initially, but yeah, so in this case, I just wanted to also just split things. So for example, I want to start transforming my column, that's categorical features, encoding the features. But in this case, I didn't want to encode the target, the the column I didn't want to include. So that's the month, the day, the time of the day. I felt like it wasn't necessary to encode, so I had to separate them. So I have my numeric features again and categorical features. Okay, so let me just quickly run this as well. Then I can now also plot this again. It just depends on what you want to see. So now I want to normalize. So using, I can create a pipeline that's, so rather than doing the imputer separately, mean masculine separately, I just want to create a pipeline, and also for the one auth encoder, that's for the categorical feature. So I just wanted to create a pipeline for them. So in some cases, you can also just, so most of the time, why it's necessary to create a pipeline, so that you have all your step itemized rather than doing them separately. Just put them under a pipeline. So when you run your pipeline, it applies it to the data for you, so you don't have to do it separately. So in this case, I don't really need to do the simple imputer again because I already filled my missing value. But this is just at least for completeness. So you don't have to, if you want to fill with mean, for example, you don't have to fill this part of the code, we do it for you. So if you want to fill with median, just make it median. So if you want to see what are the all strategies they have, you could just go browse about it. Just put simple imputer strategy to see all the different strategies you can use to fill your missing value. So I have a pipeline for my numeric transformer, that's my numeric columns, and a pipeline for my categorical columns. So this is that. Then I can create a column transformer like that combines all the transformers. That's the pipeline itself. So I just have processor. So it's telling that for the numeric column, use the numeric transformer and use the numeric features. For the categorical values, use the categorical transformer and use the categorical features. Then now all I need to do is just to apply. So by the time I apply this DF process, it just kind of applies this to it. So I don't have to call it. So I just create all my pipelines, then I just fit it to my data. So now I called it my process DF. So let me just run this, so that 25, I run this. So by the time I print out my process DF, so I have my DF. Well, if you can see, I want to see what's the type of my transform DF at this point now. So should be a numpy array, but let's just confirm that DF preprocessed now. So I want to see what's the type of data I have there. Is a numpy array and the array. Okay, so you have that. So that's the transformer. Then you can now uh so let's see, get featured name. So if you print out, because this is a numpy array, so all the featured names have been kind of disappeared because of the transformation. But you can also pull that out by using on the processor itself. You want to get the name of the transformer column using this code to just get the categorical features. So this is what this will look like. So you just to retrieve all the column names you've used as well. So this is what this would do for you, and by the time then you convert that to a data frame, yes, then you can now add. So remember initially when we did our feature, we didn't include some of the there's some columns that we didn't like the months and the target, we didn't transform those. So you can easily add them back to your data frame. Okay, so now we have our data frame with all our features. We've encoded them. So we've encoded all the categorical values. We've scaled our data. Okay, then you can now say this is just the head. I think that's the same thing. So I think that's where the whole data transformation stops for me. What I did, then I also wanted to also visualize the data again. So we visualized it before, so I applied my transformation. So now I want to now visualize the data again based on my transformation I've done. Okay, in this case, should I Let me increase this to 15 as well so that I can see it. So you notice that all our columns are now within the same limit between zeros and one. So that's what the min max scaler does. It's kind of rescaled your data so that the ones that have up to 2k just brings everything. So we have them as one scale. So if you see everything is now zero, it still retains the if you look at compare this the shape of the distribution, it's still the same thing we had initially. So it's just more like, okay, I just want all my data to be within the same threshold. So this is the histogram, then this is the box plot as well, to just see all the data. So now you can see that they are all within the same scale from zeros to one. Then with this we can now start training the model. Okay, then I can run this as well. So this is still the same thing, but in this case I ran this with SNS. I can that's Seaborn. I can also plot the box plot with pandas as well. I just did the same thing. It's just it depends on what you want to see, but at least they show you the same result. Okay. Then you can also run a correlation matrix. You can run a correlation matrix as well to see the features that are highly correlatable and why not. Then because this is too jam packed, I just want to filter out and just get some the high correlation where it's 0.1. Like you can make it 0.2 in this case. It just depends on what you want to see. I just want to see all the at least highest positive correlations. So with this I'm saying that okay, I have good correlation with color yellow as well as turbidity. At least not really good, but at least the highest correlation is where we have turbidity, where we have copper, things like that. Yeah, I didn't do anything about the identifying trends, so that's working with the time series analysis. So maybe I'll do that and also push. So after this class I'll put up this notebook on the GitHub as well. So if you go the same folder structure, I'll also put a link in the comment section, in the comment for you to go look. But maybe after some time I would work on the trend analysis to work with to see trends in the data as you move across different times like that. Well, yeah, we'll visit that later. So after processing, you can choose to save the data you have. So at least you have it saved somewhere, so you don't have to repeat all the steps. For example, if anything happens to your notebook, you want to start again, you don't have to start repeating all the steps again. So you just save and you can now reload what you've saved. So now we have a new DF. Our new DF is the processed data. So we can just, okay, let's look at what that looks like. And this is that data. So now let's start looking at, so we also want to get the numeric columns again. Want to get the numeric features. I can comment this out to look at the numeric features. Okay, and also this is for, so as feature engineering, I just created the water temperature to air temperature ratio and total metals. You can do without this, just depends on, so that this is where subject matter expertise comes in. But just okay, just for the sake of, okay, let's just create a feature. So feature engineering is just about creating features from your existing features. So in this case I just created new features as this. Okay, then numeric feature, so this, so you have it has been added. So initially I didn't want to, so in this case, so if you toggle this on, I didn't want to include the time and the day, time, and month for training the model. You can choose to, in this case, let's see if we drop it and let's see how it will affect the model. Okay, categorical. So what do we have in categorical features at this point? Color source. So I think the month has been removed already, but with, yeah, so let's just do without this for now. We'll come back to it later. So you can for when training models, what I try to do is I try different processing techniques. For example, I could try training the model with the date, the time information, the date time information, and I also train the model with it to see how the model responds to these different features being dropped or removed. So those are some ways you can really evaluate the model as well. So now I just want to create, let's see, numeric features processed. Do I need to do this as well? No, because I already created the transform div. So all I needed to do is, let's see, we already have this, so I didn't need to repeat that. Just be equals to x dot copy. Yes, I didn't have to do that anymore. So I can run this because I've already applied. Oh, I think I need to drop months. Just a minute. Just let me run this and see what the difference. Let's see, transform df dot shape. Let's see what that looks like. This is still 49. I just want to see what happened with or without that line of code. And I run these as well. 37. Okay, so I can take out the month in this case. So let me see. I just want to get only the numeric features. So in this case, I don't have my day month. I think that's fine. I don't really need that to train the model anyways. But yes. So let me just confirm this one more time. And just confirm. So this is that's 34.49. Yeah, so I'll just do without this for now. And let's just train without the month, day, and yeah, we can come back and try that to see how that differs from what we have. Okay, so let's run this. That's fine. So now let's start going into building the model. So that first of all, before you want to build the model, you want to split your data into your train set and your test set. So you have your X and Y. Your X are your features and your Y is your target. But you also want to have your train set, your test set, and your test set. I believe guys have when you had your machine learning class, they explain these different things to you. So I wouldn't want to go back. But you want to split your data into your train set and your test set. So we have our X train, X test, Y train, Y test. So you train on the train and evaluate your model on the test set. Okay, so the first model we want to try is the random forest model. So there are different parameters you have. So you can easily look at the different default parameters. You can choose to try different parameters in your data. Right, so these are different parameters. I just want to use at least these default ones. I'm using the random states so that for so that whenever I run this, I get the same results. So for reproducibility, so I'm not easy get the same result whenever I run the model. So now I run my model, fits in the model using the X train and the Y train data. Okay, let's just wait for that to run again for some time. Okay, so that's been, we fitted the model. So in this case, I want to see the results. Okay, so in this case, my accuracy is about 0.567, 567, precision I have about 0.7, and that. So because I'm going to be running this for other models, so rather than having to do this always, I just put this into a function so that I can, rather than trying to write, always call this, all I needed to do was just write this function, and all I need to do is get my X test and Y pred, and it gives you the same result. Okay, so I have a new function called get results that returns the results from the model. So now I want to, rather than using just one model, I want to compare different models to see the results from the models. Yeah, so in this case, I have a dictionary of the different models and initialization of the models. So I have logistic regression, I'm trying random forest, I'm trying KNN model and decision tree. So I'm going to evaluate them and also get the results. Okay, so let's just wait for this model to run. Let me run this. Let's get the model running.
Thank you very much. Can you hear me?
Yeah, I can hear you.
Yes. I noticed that you combined some other learning models all in one, including logistic regression, random forest, KNN, decision tree. But while I was doing my own, I think I did them separately. Like, built a model for logistic regression, ran it, and evaluated it. So that was my idea of how to carry it out.
No.
So I don't know if that is also professionally okay, or it's more professional to do it this way, or whichever approach works.
So the idea of
I'm thinking maybe they can't work together in the same. Though
so
I've never thought of it, sha.
So I'm running. So that's why when we talk about predict, rather than doing it's just about efficiency, right? Rather than trying to do the same thing for one, do again. So what I just did is create a dictionary. So I'm not running them together, but you notice I'm using a for loop to loop through this model. So more like this is a dictionary. You know what a dictionary is. So I have a dictionary of logistic regression, random forest. So what this for loop will do is we'll go through the first time, pick out this logistic regression, train the model on it and get the results. And so you see I have this empty dictionary that stores the result. So it goes through the first time, it runs logistic regression, gets the result, stores it, goes through the second time, gets random forest. Use that's how I have to specify what the model and the initialization of the model. So it goes through the second time, runs the model, goes through. So that's why I had to create this dictionary. So I'm not running everything. I'm running everything together, but they're not affecting themselves. So I feel like it's just more optimal, more efficient to do this way rather than having to do them separately. But at every point in time, the truth is that if you're learning, you can go through the things the long way. At least it makes you understand. Then when you understand the process, then you can now start applying all these other methods. So like for example, creating a function, you don't have to create a function. For me, it just helps me keep things clean instead of having to repeat the same thing over and over again. You get, so this is just me. I just want to quickly try different models and see the result. So I've trained the model, I've gotten the result. So if I print out the result, this is what that DF looks like. So for logistic regression, the first one I went through, this is the accuracy. For the next one, so it just goes through like that to just get the result for all of them. So what I would have done, let's say in 4 lines, having to repeat just in code cell, I just did it once with for loop, and this is where for loop kind of is very good. It just helps you automate things rather than having to do them one after the other. Yeah. So that's it. Then I can now easily compare the model. So I just did a visualization to plot to see, okay, which with this I can easily see which model is doing better. So I can see, for example, the first one is accuracy score. My random forest has the highest accuracy score. Let me see if I can include a grid. PLT dot grid to show the grid so you can see grid fields. So for example, our accuracy score for random forest was the highest compared to at least the next one was decision tree. Then for recall you had the highest also in so generally a random forest is doing better than other model. So with this, I can say, okay, this is the model. So I can just use this to get the best model. So automate. So for example, I change some things and random forest is no longer doing well. This code just picks out the best model for me. Then I can also plot a confusion matrix. So aside just comparing using accuracy score, you want to see confusion matrix to see where is the model confused. So since the best model is random forest, I'll just use random forest anyways. So I also created a function to plot my confusion matrix as well. So for random forest, I have so it's able to predict let's say 11,000 of the true value of the zeros correctly and about 5,000 of the ones correctly. So this other diagonal just shows where the model mispredicted. So the true label in this case is 0, but for about 1,853 times, the model predicted them as 1. So the model is kind of predicting some things wrong, and you want to see which is it predicting. So the model is not is predicting some zeros as one and predicting some ones as zero. So that's why that just shows you. So ideally you want to have at least good enough prediction correctly. So what the model predicted that was correct than what the model than the wrong one. So this is what gives you the accuracy score. The idea of the accuracy score. Okay, so this just also I just wanted to okay, based on the thing, you want to get your feature importance to see which features are doing best with your model. So what's the error? Okay, I think mm, so I don't need this other part. So let me just because of that thing I toggled off. So I can take this out as well. So I want to see which of the features the model is predicting correctly, which features had the highest prediction. So, for example, we have our manganese as the highest important, followed by pH, followed by turbidity, things like that. So yeah, so with this, I just wanted to see based on those high important features. Just wanted to see if I could get any trend at all using scattered metrics. So scattered plot, so you don't have to do this. But this was just okay. Let me even see based on those important features, how do they relate to your target variable? Okay, then these are some, you can just read up this. So what I just wanted to touch on quickly was the hyperparameter tuning. So you can also adjust. So it's more like adjusting the different. So for example, you want to you want to cook your food. You have the proportion of different ingredients you want to use to cook your food. To achieve the best result, you should know what the quantity of salt I should add, what's the quantity of water, what is the quantity of heat I should do. So adjusting those quantity, that's what hyperparameter tuning is. These different models, they have different features or different parameters in them. So to get the best result, you may want to tweak things a bit, adjust a few things until you get the result. So there are different ways to tune hyperparameter. You could do random search CV, or that's the grid search CV or random search CV, or you do manual tuning. So in this case, I was attempting to do a grid search, but it's going to take a long time. So I just stopped it there. You can try it if you have enough time, run this cell code. Then, but based on that, I think that's the best parameter for logistic regression. That's what I was able to run before I stopped it because it was taking a long time. These are the parameters, combination of parameters that would work well for your logistic regression to get the best result. For X, then, as I know we've tried about 4 different models, I also wanted to try a different model, SG, because generally it performs really well when it comes to classification. So I also tried this out as well. So if I train the model, let's see. Let me take this out. I want to use. So let me train the model again. And so in this case, you see why it's good to create function. So rather than trying to repeat everything to get result, all I need to do is call that function, and gives me the results of the thing. So for example, I'm getting my accuracy at 0.856. I think it's close to the random forest method. So also you can also try to train the model. So I wanted to also try grid search CV to also search for the best combination. So I gave it a list of parameters it should try for n estimators, try 50, try 100, try 200 for length, try the different way and give me the best result. So it returns that this is the best parameters to use to train the model and to increase your prediction to this accuracy. So I just train the model again using those parameters, and you see that the results would has improved from the previous result. So initially it was the accuracy score was 0.856. In this case, I've increased it to 0.864. So I could also do a confusion matrix as well. So in this case, I see that let me compare this with the confusion matrix of the random forest. Let's see, model, saying that model was model RF, not RF. So in this case, let me see, random forest. So let's compare the results from the two models. You see that the random forest is able to predict more of the zero class correctly, more than you have, I think, yeah. So it's still about the same thing. So what this SG Boost model doing better is being able to predict the one class, so they'll target one correctly more than the random forest method, and it's being able to predict also the RF more than the like, so it reduced the wrong predictions of the first class compared to RF model, but increased. So it's just about looking at these different models and looking at which, based from what I understand about the data, which model would which model would do better for me. Looking at it generally, you have higher accuracy score for SG Boost model, but that does not mean it's better. So you have to come back and start looking at the confusion metrics. What category is it predicting correctly compared to the others? Okay, I think that's a long time, like a long, and I think can be complicated. But if you, I think the session is recorded, you can always go back, listen to it, and at least try them out. I'll also push those solutions to my GitHub as well, so you can easily go there and also check out the results and also try it yourself. Okay.
Thank you very much for the solutions. I've been able to pick several things that I can improve upon going forward, because I really hope to carry on with the project as far as I can, to see if I can, because for a while I've always been more interested in anything geoscience related, especially because one can easily apply domain knowledge compared to just trying your hands on data from other fields that you might not really have a very deep knowledge of what interests them, or what are the important areas to watch out for as you are doing your analysis. So I will just further thank you for your kind support so far. And if I have any question, yes, when you were mentioning confusion matrix, I remember that I've seen something like that, but it didn't come to mind when I was actually dealing with my own model. So I really don't know, would like what's like the significant impact skipping matrix might have on your model. That's, imagine I didn't do mine right. So like, was is there any significant impact it can have on, maybe if you are releasing it out to people that want to use it and all of those things,
So I think
or you
for
want
me,
to deploy it, maybe is a better word.
for me, I think what the confusion metric just shows is just gives you an idea of what how your model is performing. So you can say the model is performing well in predicting XYZ class. So it gives you that idea. So it's just, there's no like impact or negative impact of not doing it. It just gives you that this meeting is going to end. I didn't want to start again, but I think we just have to start just to wrap up, quickly wrap up. So it just gives you an idea. So with this, I can know that, oh, my model is being able to predict my zero class very well. So that, because there's no model that is 100%. So you want to say, okay, what's the strength of this model? What's the strength of this model? So for example, you could have one model that is predicting a particular class correctly. So when you deploy the model, you say, okay, this model is very good in predicting this class. You could have another model that is very good in predicting another, but it just gives you an idea of how the model is performing in general. Can you hear me now? So I was going to talk about this. This one is just about going through a large data set to look for the data that actually contributes to the result you're trying to achieve. So it's about searching through a large set of numbers. So this is totally different from mining. You could maybe data exploration it depends on this. Well, some of this is just about definition of terms. It's about discovering patterns in your data, going through the data. But with that, you can maybe classify the first part of what we did, trying to understand the data, analyze it, doing the EDA as part of data mining. But it's just everything just about having the right definition. But it's I think this project was more focused on model building, training machine learning models, and also evaluating the models to make prediction. Yes. So I think ideally what I want to even try with this model, that's why I wanted to test different people's models, get is a new set of data so that because you also have overfitting, your models can be overfitted. So it's more like based on maybe if there's a form of data leakage, like when Paul had about 0.9% accuracy. Yeah, it's a good number, right? Almost 90% accuracy. But what if you have some data leakage there? What if your model has been overfitted? So an overfitted model is a model that performs very well on training data, but when it sees a new data, it performs very, very poorly. So I can bring a new set of data similar to this structure and see, let me test your model to see what the result looks like. Yeah. So these are the differences you can start looking and spotting. Okay. So before we log off finally, any last questions? Anything you need clarification on?
Yeah, thank you. The last email we got is looking as if the whole training is not over yet. I'm still seeing something like maybe a final project or something like that.
Which email? I don't know if that's because I think the plan initially was to have two projects, but because of how things went, like we couldn't have two because we need an extra session. So it's okay to give you a project, but we don't have time to go over it. So this week is the last week. So maybe the organizers
Okay,
can communicate back to you on that. Well, I didn't see the need of giving a project where I can't at least provide a solution so that you're not
okay,
just hanging on the air. So that's why I just took this sessions to let's go over the results of what we've learned.
okay. So, are we going to have certificates at the end of this week's session, or that was not budgeted for?
I'm not sure. I'll just confirm because I'm just like a facilitator. I'm not part of the
Okay,
organizers. So you could maybe send in an email for them to just confirm if
okay,
you're going to
we
get a
need
certificate on
inquiry.
that. Yeah.
Okay, okay. Going forward, please, I will, like I said, I will try as much as possible to continue further on the project and see how far I can make it better. Then maybe I'll send it to you
Okay.
for maybe review at your leisure time.
Okay, sure. That's fine. That's totally fine.
All
Fine.
right, thank you.
Okay. Okay. In absence of other questions or comments, I'll just end the meeting. And it's been an amazing time working with you all. Shagun, you want to say something?
Yeah, I just want to appreciate all your efforts for all what you do, and I pray that God will continue to bless the hands of your work. You have been doing well. Then I will also try to improve on the model. Then I'm also trying to work on one petrophysical data set and trying to do some kind of analysis. When I'm done, I can also share the Python file with you. Thanks
Okay.
so much. And
No worries.
I enjoyed the moments. I actually enjoyed the moment during the course of this training. It's awesome. And this is a good one, and we can continue to build on this knowledge. Thanks so much.
Yeah, no, that's fine. Thank you so much. So I don't know if you can reach out to me on any social media platform. I should be able to respond to you as soon as I can. And just let me know if you're working on things. I also have a YouTube channel if you don't know, so you could follow me there as well. So I'm just kind of building a community of young people that are interested in similar things so we can all grow and work together. So reach out to me, share your notebook with me, share your ideas with me. Let's see how we can help ourselves.
Thanks so much.
No worries.
and I already subscribed to your YouTube channels for a
Oh,
long time anyway.
okay, no worries at all. Thanks so much for that. And just try to also, if you have questions as well, you have comments, and in most cases, you don't always have to agree with me. So it's good to have contrary opinions. So just about, okay, let's have intellectual conversations as well. So I try to tell people I don't know everything. I don't always get it right. I could make a mistake. So if, for example, I do something, say, oh, I don't think this is the right way to do it, or you have other better ideas. The whole idea is we're all sharing knowledge and we're trying to help ourselves. What language is that, Olusegun?
Nice Portuguese.
Oh, obrigado. No, I know obrigado, but I don't know the muito.
Mental means thanks so much. It means
Okay,
thanks so much.
obrigado. Paul.
Yeah, thank you. Um, Please, I would also like to know something like after the deployment, like let's say you've finally gotten your model ready for the team that maybe I believe there are other team of engineers that you build model and hand it over to them, right?
Okay, yeah,
Is that correct?
yeah.
So going forward, what does the future of the model look like in terms of maybe you will have to revisit it again, and just like for instance when you build a car for you build a car and maybe a company builds a car and gets it out to the public to use. So maybe after some time based on feedbacks they've gotten from users, maybe they feel that there's something they can improve on, going further as they continue to produce more and more units of that product. Is there anything like that kind of idea in
Yeah,
the lifetime of a model,
yeah. So now it now depends
and how
on
does it look like?
it depends on the platform you're using to deploy your model, because you need to deploy. So when you talk about team, in some companies, you that produce the model could be also the ones responsible for deploying the model. In some cases, it will be
Okay,
a different team. So it depends on the platform you're
okay,
using. You can improve the model. So based on feedback, if you say, okay, for example, if you notice that the model is not doing well on a particular class, it's okay, maybe I get more data and we build the model, we train the model and we deploy it. So it's just about improving the model. So you can there's always the different platforms for deploying models. So some platforms you can retrain the model. So in some cases if you have more features, or if you have more data sets, you can add it and retrain the model again and feed it in. So and most of the times it's good to create pipelines, more like, so that you remember all the transformation we've done. If, for example, I want to apply that model in a new data, I have to start applying all the transformation. But if I kind of feed it in a pipeline, all you need to do is, okay, these are the columns I need. You tell, like, for example, whoever wants to deploy the model, these are the columns that would be useful, that was used to train this model. So those are the things you get. Then all the pre-processing you've done, because you fit it into a pipeline, it just applies that pipeline to the data, and you can predict the model. So yeah, because for example, if you have a different team that is deploying your model, you won't pick out your, you won't take out this whole notebook and give to them. It's going to be confusing. So you want to make things concise. If you need to put things in function, create pipelines that just does different things for you, that handles different part of the data. So all you need to do is just to export the model. So remember I mentioned exporting model. Did I show how to export model? Yeah, we can just export the model, and that's the model they would then use to train to for deployment.
okay. So thank you for your feedback. So which I want to infer something from that. Does that now mean that as an ML engineer, if for instance you have maybe the other people that have to take over from where you stop, does it mean that throughout the lifetime of that model, it's most likely that your service is no longer required except there are new projects that are coming up?
Yeah, it depends on how the company structure work, because you still need to maintain the model. For example, if you deploy the model, you can tell them we want to monitor the model for the first XY amount of months to see how it's doing and also improve. So you can also, if it depends on the kind of data you're working, is it data that you're always generating that you always need to train, or you could also have other projects you're working on. So if you work on a model, if it's the structure of the company is you work on it, the model, generate a model, and hand it over to somebody else. Yeah, that's fine. Maybe you get another thing to work on, or in some cases you need to also improve on the model.
All right. Thank you very much.
No worries. Thank you. So different companies work in different structure.